So let's take a look at number 64 in your book. Number 64 actually says, find the rational zeros and then the other zeros, that is solve for f of x equals 0 and then factor into linear factors. We've done this in section 4.3, but it was a little bit different from what we're doing now. So when I look at the work and I take a look at my function, which is this one, and it is a function to the fourth power, so it has a degree of 4, and I start trying to factor this with my traditional methods. I take a look at it and I say, okay, it's got more than 4 terms in it, so I can't use grouping. There's not a common term in all of them, so I can't pull that out, so I'm stuck. So what we're going to do is we are going to put this function on the calculator and put this function in Desmos and see if we can actually find a 0 we can use. So we'll look at Desmos first. So we're just going to hit start graphing, and we're going to type in our function just like we see it. So let's see, number 64 says 3x to the fourth minus 4x cubed. I think sometimes the hardest part is getting it typed in correctly. So minus 4x cubed plus x squared plus 6x minus 2. And what we're looking for are zeros. So we look at this one and we see a 0 here and we see a 0 here. And we want to use whole numbers if we can. You know, if we didn't have a whole number, take for instance if this is the only one that I had, and you can see that it's between 0 and 1, we could actually use the rational zeros theorem. And what we would do is we would take the last number and the first number in our function, and we would take all the factors of the top one, so 1 and 2, and all the factors of the bottom one, and we would do a plus and a minus for both of them, and we would divide the bottom over the top. So we would have 1 over 1 and 1 over 2 and 1 over 3, and then 2 over 1 and 2 over 2 and 2 over 3. And we would of course have pluses and minuses of both of those. And so since on our graph we had something that was between 0 and 1 that was a 0, and it said 0.33333, well this number is 0.333, so we would be able to use 1/3 as our 0 that we're looking at. Luckily, on the one that we are looking at, we actually do have a whole number we can use. So we have a -1 that we can use. Now, if we were on our calculator, let me pull up the calculator. So we would type it in just like we did the other one. So 3x to the fourth minus 4x cubed plus x squared plus 6x minus 2. And we would graph it, and hopefully when I look at it I'm going to see a whole number I can use. I'm not sure that that's a 0, that that's a -1. So what you want to do is look at your table, and you're looking for the ones that have a y, which is a 0. So that would be a -1. I don't see any other down through there. So, you know, if your table's not set correctly, if you hit second window, you can actually set it so that it will automatically do a table for you. So this is what yours would want to look like if you needed to set it. But we've confirmed now that we have a -1 that we can use, so we're going to use that to get started. So what I've done is I've taken the coefficients for my problem and I've taken the -1 that we said was a 0, and I'm just going to do synthetic division with it. And we're going to confirm first that it is a 0. And since I have a remainder of 0, it is indeed a 0. Now since our leading term, our leading degree was a 4, this one's going to go down to a 3. And at this point, if it was something that could be factored, so I've got 4 terms here, if I could actually pull out an x squared and be able to factor this using grouping, I could do that. But again, this is not one that can be factored traditionally. So what I'm going to have to do is I'm going to have to put this in my calculator or on Desmos and find another 0. So I'm going to pause this and put this on Desmos. So we've put our new function in here, and when I hover over it, I don't have a whole number. So what we're going to do is we're going to use that rational zeros theorem, and we're looking for something between 0 and 1, which we've already done. This is 1/3, and it's a positive 1/3. So we are going to take 1/3 and do synthetic division with this one. So you can see I've started my synthetic division. 1/3 times 3 is 1. Minus 7 plus 1 is minus 6. 1/3 times minus 6 is minus 2. 1/3 times 6 is 2, so it is indeed a 0. So now let's see, we've got a 3, a minus 6, and a 6. This was a 3, so it's going to go down to a square. So 3 minus 6 and 6. So the one we were just working on had a degree of 3, so this one's going to go down to a 2. And let's see, I believe we can factor this one if we pull out a 3. And let's see, are there factors of 2 that give me minus 2? Well, the only factors of 2 are 1 and 2, and that's not going to give me a minus 2. So we're stuck with using the quadratic formula. So we've got, right now, we actually have the original 0. We have this 0 that we used. And then we have this expression. Okay, so our zeros right now, if we use the quadratic equation, we have minus b plus or minus the square root of b squared minus 4ac, all that over 2a. So 2 plus or minus 4 minus 8 is minus 4. So the square root of minus 4 is 2i. These all cancel. So we end up with 1 plus or minus I, which counts as 2 zeros. So we have 2 zeros here, a 0 here, and a 0 here. That's 4 zeros. Our function started out with a degree 4, so we know we found all of them. Now, if we actually wanted to factor this, we could go back to this one so that we didn't have this I in here, because this one can't be factored without these imaginary numbers. And we could write for our factors 3 times x squared minus 2x plus 2 times this factor would be x plus 1. And this factor, if we had x minus 1/3 equals 0, which that's where zeros come from, if we bring the 1/3 over and we multiply both sides by 3, we would have 3x minus 1. And this one is a little tougher than some of the others that you'll have because it had multiple steps to it. But this one, what we did is we went through and we found the zeros on the calculator for the first go around. We used that 0 then to use synthetic division, and hopefully it was something that could be factored. It was not. So we put it in our calculator again and looked for another 0. We used synthetic division with that one and tried to find something else that could be factored. the thing that we got at the end was also something that couldn't be factored, so we ended up having to use the quadratic formula. Now that's what's going to happen. You're either going to have something that's going to be factored, or you're going to have to use the quadratic formula. But you can see with this one, this is the first one we've done that you've actually had to use the process multiple times. That's not always going to happen, and I'm probably not going to give you any where you have to do multiple times, but this is what you would do if that were the case.